See, so far we have studied under Galilean transformations in two reference frames, S and S dash. Length does not change. Then laws of mechanics does not changes. Law of conservation of momentum also remains same. Then lastly, we have to prove the law of conservation of energy also does not change. You know that collisions are of two types. One is elastic collision. Another one is inelastic collision. What is elastic collision? The kinetic energy of a colliding bodies before collision is equal to kinetic energy of the colliding bodies after collision. This is elastic collision. What about inelastic collision? So, kinetic energy before collision is not equal to kinetic energy after collision. What happens? In the case of an inelastic collision, part of the kinetic energy appear in the form of heat or some other form of excitation energy after collision, and the rest is kinetic. So in the case of inelastic collision, law of conservation of energy does not hold good. What happens? Before collision was okay, but after collision, in the case of inelastic, part of the kinetic energy appears in the form of heat or some other form of excitation energy, and the rest is kinetic. What is the meaning of this? See, in the case of inelastic, collision, so total kinetic energy before collision is equal to, so kinetic energy plus delta E. What is this delta E? This delta E after collision appears in the form of heat or some other form of excitation energy. Means what? See, kinetic energy before collision, assume that it is 50, and in the case of elastic collision, this 50 is equal to 50. But totally it is kinetic. But in case of inelastic collision, say this may be 40, this may be 10. What is that 10? So that is after collision, it may appears in the form of heat or some other form of excitation energy. And in the case of inelastic collision only, we have to prove the law of conservation of energy. So, consider in S frame, kinetic kinetic energy before collision, kinetic energy is half ma square, half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square plus your delta E. What is this m1, m2? m1, m2 are the absolute quantities of mass of body 1 and body 2, colliding bodies. u1 and u2 are their velocities before collision. v1 and v2 are their velocities after collision. In S frame, you know that in S dash frame, ux velocity transformations x dash is equal to ux minus v. Tell me what is this ux dash and ux? Ux dash is the velocity of an event in S dash frame. Ux is its velocity in S frame. What is V? V is a uniform velocity with which this S dash frame is moving. From this equation I can write it as ux is equal, means in x frame, what? It is ux dash plus v. This is S dash frame, now it is S frame. Now these are in S frame. I will write using these equations u1 in S frame is equal to u1 dash plus v. Tell me what is u1 and u1 dash? u1 is the velocity in S frame, u1 dash is velocity in S dash frame. Next, similarly, can you write what is u2? u2 definitely it is u2 dash plus v. And write what about v1? So your v1 is equal to v1 dash plus v. v2 is equal to v2 dash plus v. u1, v1, u2, v2. Substitute all these values in this equation 1. Now we have to substitute these values of u1, v1, u2, v2 in equation 1. This is half m1 is as it is u1 square. Your u1 square is u1 dash plus v. It is u1 dash plus v whole square. Then plus half m2 inside the bracket. What to write? u2 is u2 dash. You write down this simultaneously. Plus V whole square. You write down this. This is over. That is equal to what? Half m1. Now v1 square. What is v1 square now? v1 is this one. v1 dash plus v whole square plus half m2 into v2 dash plus v whole square, assuming delta E, that means either in the form of heat or some other form of excitation energy, is the same in both the frames of reference. ಇಲ್ಲಿ ಏನು ಅಸ್ಯೂಮ್ಷನ್ ಮಾಡಿದ್ನಂದ್ರೆ ಅದು ಏನು ಎಕ್ಸ್ಟ್ರಾ ಹೀಟ್ ಆಫ್ಟರ್ ಕೈನೆಟಿಕ್ ಆಫ್ಟರ್ ದ ಕೊಲಿಷನ್ ಸಿಗ್ತೈತಲ್ಲ, ಇಟ್ ಈಸ್ ಸೇಮ್ ಇನ್ ಬೋತ್ ದ ಕೇಸಸ್, ಎಸ್ ಅಂಡ್ ಎಸ್ ಡ್ಯಾಶ್ ಫ್ರೆಂಡ್. ನೌ ಯು ಸಿಂಪ್ಲಿಫೈ ದಿಸ್. It is a plus b whole square. This is half m1 u1 dash square plus 2 u1 dash v plus v square plus half m2 u2 dash square plus 2 u2 dash v plus v square plus that is equal to that is equal to what? Half m1 v1 dash square plus 2 v1 dash v plus v square plus half m2. Inside the bracket what I will write? v2 dash square plus 2 v2 dash v plus v square. You write down this. So of course here this is plus delta E. See here, because board is not sufficient, half m1 v square, half m1 v square, that is quantity and also half m2 v square. This is half m2 v square, they cancels. If you take them any one side, one becomes positive and another becomes negative. And write the remaining things. This is half m1 u1 dash square. This 2 and this 2 cancels. Isn't it? Yes. So, plus m1 u1 dash v. Then this has been cancelled. So, plus half m2 u2 dash square. And again these two cancels. m2 u2 dash v. This is what left side. That should be equal to, this is half m1 half m1 v1 dash so plus m1 v1 dash v, sorry, v1 dash v, and this has been cancelled already, plus half m2 v2 dash whole square plus m2 v2 dash v. So plus your delta E. You write down and check this equation once again. Bari ma check ಮಾಡಿ correct ಐತಿ ನೋಡ್ರಿ. Then from this it is half m1 u1 dash square, this quantity. I will take this quantity also, plus half m2 u2 dash square, this quantity. See from these two equations, take that v outside plus v, what remains inside the bracket, m1 u1 dash plus m2 u2 dash, and left side is over. That is should be equal to, so half m1 v1 square half m1 v1 square plus half v1 dash square, yes, half m2 v2 dash square. Once again from this you take v outside plus v m1 v1, I think it is dash m1 v1 dash plus m2 v2 dash plus, of course, delta E. But from the law of conservation of linear momentum, already we have proved that m1 u1 dash plus m2 u2 dash should be equal to m1 v1 dash plus m2 v2 dash. This is what the law of conservation of linear momentum. Therefore, this quantity on either side cancels because of the law of conservation of momentum. So what remains here? This is half m1 u1 dash square plus half m2 u2 dash square, then that should be equal to half m1 v1 dash square plus half m2 v2 dash square plus delta E. So call this equation as 2. And this belongs to what? S dash frame. From this, it is clear that the law of conservation of energy is invariant, because this is law of conservation of energy in S frame and this is law of conservation of energy in S dash frame. The law of conservation of energy is invariant under Galilean transformations. So, what is non-inertial frames of reference? And under that, you should know what is fictitious force. So, in a frame of reference, if a Newton's law of inertia does not hold good, does not hold well, that frame of reference is called as a non-inertial frame of reference. So, a frame of reference in which Newton's law of inertia does not hold good, that frame of reference is called non-inertial frame of reference. Already we have discussed about it. An example of this non-inertial frame of reference is any frame of reference which is accelerated. A frame of reference which is accelerated, or a frame of reference which is moving along a circular path, whether it is linearly accelerated or angularly accelerated, that frame of reference is called as a non-inertial frame of reference. So consider this is one frame of reference represented by S. It is inertial frame of reference. It is an inertial frame of reference, and there is another frame of reference which is non-inertial frame of reference. One is inertial, another one is non-inertial, and let this non-inertial is represented by S dash. Assume that in this inertial frame of reference there is one particle of mass m. Then let us consider this non-inertial frame of reference is moving with an acceleration is a0. AO is the acceleration of this frame S dash. And a person in this frame S dash observe the mass, observe the particle which is particle or a body which is lying in the S frame. But this person is in motion, and the acceleration of this frame is a0. For him, this body appears to be moving with an acceleration a0 minus a0. Actually, this body is not in motion, it is at rest. But for him, since he is moving, appears to be having an acceleration of minus a0. If, for example, now bus ಅಥವಾ car ನೋಡೋ fast ಹೋಗ್ತಿರ್ತೀವಿ. That means car or bus having an acceleration, isn't it? So road ಬಾಜುಕಿನ ಗಿಡ ನೋಡ್ತೀವಿ. ಅವಾಗ ಗಿಡ ಅಲ್ಲೇ ರೆಸ್ಟ್ ಪೊಸಿಷನ್ದಾಗ ನಿಂತಾಗ ಅನಿಸ್ತಿತ್ತು, ನಮಗೆ ಅನಿಸ್ತಿತ್ತು. ಇಟ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್, ಅಪಿಯರ್ಸ್ ಟು ಅನಿಸ್ತಿತ್ತು, ಅಥವಾ ಫಾಸ್ಟ್ ಮೂವ್ ಆದಾಗ ಅನಿಸ್ತಿತ್ತು, ಮೂವ್ ಆದಾಗ ಅನಿಸ್ತಿತ್ತು, ಅಪಿಯರ್ಸ್ ಟು. ಸೊ ವಿತ್ ವಾಟ್ acceleration? The acceleration with which the bus is moving, other acceleration ನಾವು ಹೋಗಾಕತ್ತೇವ ಅಂತ ಅನಿಸ್ತದೆ. So in the same manner here, actually this body is at rest, but another frame of reference is in motion. If this frame of reference is in motion, then its acceleration is AO, and definitely the absorbed acceleration on that particle of mass m is minus a0. So ಇಲ್ಲಿದ್ದಾಗ ಅದು ಅನಿಸ್ತದೆ, it is having acceleration. Then another thing is, if a body is having an acceleration, Definitely according to Newton's law, a force acts. So ಯಾವುದೋ ಬಾಡಿ ಮೇಲೆ ಎಕ್ಸಲರೇಷನ್ ಬೀಳ್ತಿತ್ತು ಅಂದರೆ ಎಕ್ಸಲರೇಷನ್ ಹೊಂದಿತ್ತು ಅಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಆ ಬಾಡಿ ಮೇಲೆ ಏನೈತ್ರಿ there is a force. And this force acting on a particle is Fo is equal to, it is mass into acceleration minus m a. This force appears to be acting on a particle of mass m for an observer who is observing that in the non-inertial frame of reference. So, is that force is actually acting on a particle? No. That force is not actually acting. But for a person, that force appears to act. In other words, a person who is in the frame of reference S dash observes a force Fo is equal to minus MAO is acting on that particle. Such a force which appears only due to an acceleration of a frame of reference is called fictitious force, or sometimes it is called as pseudo force. So PESUDO. So a force ಏನಂತ ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ fictitious force ಅಂತ ಹೇಳ್ತಾರೆ, pseudo force or apparent force. See, there is no acceleration of a particle actually which is lying in the S frame. But for a person who is observing from the accelerated frame of reference, so that body of mass m appears to be moving with an acceleration a0. Since it is moving away from that body of mass m, it is minus a0. If a body is having an acceleration, so definitely we can say that a force acts. Is the force actually acting? No. But for him, the force appears to act on a particle of mass m. This force is given by Fo is equal to minus MAO. Then, what about this Fo is equal to minus MAO? So, this force appears to act. Why? Due to an acceleration of a frame of reference S dash. And such force is called as fictitious force. Sometimes it is called as an apparent force. Also it is called as an pseudo force. So they may ask you, what is fictitious force? A force which appears to act on a body due to an acceleration of the frame of reference is called fictitious force. This fictitious force is given by Fo is equal to minus MAO. Then what is the net force acting on this particle? Or what is this total force acting on the particle? So assume that this particle of mass m is at rest in the earlier case. Now certain force acts on this particle producing an acceleration AI. What is AI? Acceleration of that particle in the inertial frame of reference. ಈಗ ಸೆಕೆಂಡ್ ಕೇಸ್ನಾಗ ನಾನು ಏನು ಹೇಳಾಕತ್ತೇನೆ ಅಂತಂದ್ರೆ there is a certain force which is acting on that particle. Then the condition of the second frame of reference is same, it is in motion. ಇದು ಮೊದಲು ಯಾಕೆ ಮೂವ್ ಆಗತ್ತಲ್ಲ ಈಗೂ ಮೂವ್ ಆಗತ್ತೆ. But when certain force acts on the particle in the inertial frame of reference, so that force is given by Fi is equal to m into AI. So what is Fi? Force, actual force acting on the particle in the frame of reference S. But this is in motion. He observes the pseudo force also of fictitious force. Then what is this Fo? A net force. So net force acting is F dash is equal to F I plus Fo. So what is this Fo? Fo is a fictitious force due to its motion. Fi is an actual force acting. So what is Fo here? Here Fo is equal to minus m A naught. Or this is your F dash is equal to, you know that it is m AI minus m A. Or this is m AI minus u. All this equation is 1 and this is equation 2. Now this F dash is what? A net force acting on the particle. This net force is equal to total mass of the particle and this total acceleration is AI minus u. So the total force acting on the particle of mass m in the S frame is, it is F dash, its total acceleration is AO minus AI minus AO. Assume that this Fi is equal to 0. What do you mean by Fi is equal to 0? Fi is equal to 0 means no force is acting on the particle of mass m in the frame S. Then definitely here this is F dash is equal to what? F. This is equal to minus m A naught. From this it is clear that even though an external, in the absence of an external force, a fictitious force acts on the particle. In the absence of an external force, a fictitious force acts on the particle. So this fictitious force comes into play. Why? Due to a relative acceleration of the non-inertial frame of reference. So what we have discussed is, what is a non-inertial frame of reference? A frame of reference in which Newton's law of motion does not hold good is called non-inertial frame of reference. A body which is accelerated either in a linear motion or in the circular motion, so is called as a non-inertial frame of reference. So consider two reference frame S and S dash. So S is an inertial frame of reference in which the Newton's laws of motion holds good. S dash is a non-inertial frame of reference in which the Newton's law of motion does not hold good. Assume that this S dash is moving with an acceleration A naught or AO. Let us consider a particle of mass m is lying in the S frame, and an observer who is in the S dash frame observe this particle. Since this frame of reference is in motion with an acceleration a naught, for him this body appears to have an acceleration. This body appears to have an acceleration. What acceleration? It is minus a. Once a body is having an acceleration, definitely certain force acts on that body. Then what is the expression for force? Fo is equal to minus ma. So next question is whether this force is existing really or not, which is not existing. But it appears for us, there is a feeling, psychological feeling. What? This force appears to act on a particle of mass m, but particle of mass m is at rest in the airstream. The force which is appears to act on a particle due to relative motion, due to relative acceleration of another frame of reference. So that force is called apparent force, fictitious force, or also it is called as pseudo force. Then this is the first part. We have defined what is pseudo force or what is the fictitious force. Consider second time a force Fi acts on this particle producing an acceleration Ai. So second case S frame the ENR force act. Then that force Fi is equal to m. I stand for inertial frame of reference. Now what is the net force acting on it? This person is in motion. It is having an acceleration. The total force acting is F dash is equal to Fi plus Fo. What is Fo here? Fo is minus ma naught. So net force is F dash is sum of the two forces, a real force plus actual force plus fictitious force. So this is what MAI minus A naught. So what is the net force? Net force acting on a particle is F dash. So net acceleration of this particle AI minus A0. So let us first consider if Fi is 0. If Fi is 0 means what? No force is acting on the particle. So if no force is acting on the particle, F dash is equal to F0, which is equal to minus m a naught. And this force is really a pseudo force or fictitious force. So even in the absence of an external force, a force appears to act on a particle of mass m due to acceleration of non-inertial frame of reference. Then let us discuss some examples of this fictitious force. So consider in a lift there is a particle of mass m. It is vertically in motion, and definitely on this it is an accelerated frame of reference. A force acts. What is that force act? This force acting on this particle Fo is equal to minus mg. So it is a force appears to act. But there is another force which acts in the upward direction also, opposite to this. So that force is Fg is equal to mg. This is not a fictitious force. For a body which is at rest, there are two forces. One is acting in the upward direction, another one is acting in the downward direction. Now your total force acting on this is minus mg plus mg. And this is equal to what? 0. Means what? Though the body is having mass m, but total force is 0, the body appears to loses its weight. This condition is called as weightlessness. So, ಈಗ lift naga vertically on body ಕೆಳಗಡೆ ಆಗಿರುತ್ತೆ. Fictitious force is minus mg, upward force is plus mg. The resultant force acting is 0. 0 means that body don't have any mass. This condition is referred to as weightlessness. ಈ ಕಂಡೀಷನ್ ಏನಂತ ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ weightlessness ಅಂತ ಹೇಳ್ತಾರೆ. Then consider another example. If a body is moving along the circular path, we know that the particle or a body experiences a centripetal force. Therefore, it is having centripetal acceleration. And this centripetal acceleration is given by A is equal to omega square into R. What is omega? Omega is the constant angular velocity of the particle. And there is a force acting on this particle. That force which is acting towards the center is called centripetal force. And definitely to balance this, there is another force acts away from the center. That force is called as what? centrifugal force. So you know that particle is in the frame S, then observer is observing the motion of that particle from a frame S dash. So particle is in the frame S, observer is observing because this frame is rotating, and the centripetal acceleration in this case is given by, it is minus omega square into r. Generally I have told it is omega square into r. When we are observing this particle with in the inertial frame of reference. But if the motion of the particle is observed from a rotating frame, its acceleration is opposite to this one. So A is equal to minus omega square into r. Then the fictitious force acting on this particle is given by Fo is equal to, you know that it is minus m into A naught. It is a fictitious force. So for this A naught, if you substitute this one, this is m omega square into r. So in this case, this fictitious force is nothing but centrifugal force. We know that the force which is acting away from the center means r is a position vector of the particle, and this centrifugal force is directed away from the center. So this is another example of fictitious force. So we know that, forget about this S and S dash frame. If a particle is moving along the circular path with a constant speed, a force acts towards the center of the particle, which we have studied at KUD first year. And that force is called as centripetal force. And definitely there is an outward force also acts on the particle. That force is called as centrifugal force. So there, this centripetal acceleration of a particle in general is given by A is equal to omega square into r, where omega is angular velocity of the particle, r is the radius of the circle. In this case, consider particle is in the frame S and observer is in the rotating frame S dash. He observed this particle, motion of the particle. Then for him the centripetal acceleration AO is equal to minus omega square into r. This you should know already. Use first year. So omega is angular velocity. R is the position vector, or it is also called as a radius vector. Then in this case, fictitious force is given by Fo is equal to minus m AO. Expression for fictitious force. If you substitute this, this is m omega square into r. An important feature of this, or aspects of this fictitious force, it enables us to determine whether a given frame of reference is accelerated or non-inertial or not. So consider two frames of reference. S and S dash. If the relative motion between them is uniform. What do you mean by the relative motion between them is uniform? See, one is at rest, assume that another one is moving with 5 meter per second constantly. And what is this relative motion? It is 5 meter per second. ಒಂದು ರೆಸ್ಟ್ನಾಗ ಐತಿ, ಇನ್ನೊಂದು ವೆಲಾಸಿಟಿ ಚೇಂಜ್ ಮಾಡೋದಂದ್ರೆ ಕಂಟಿನ್ಯೂಸ್ 5 meter per second walk. It is a uniform relative motion. That means acceleration, relative acceleration is 0. A 5 meter per second is the 6 meter per second or acceleration. There is a uniform relative motion. Then definitely both of them are inertial frame of reference. In other words, if one is accelerated, then this 50 GS force comes into play. Then accelerated frame of reference, if it is there is what? A 50 GS force. So 50 GS force gives an important information whether a given frame of reference is inertial or it is non-inertial. If two frames of reference are in uniform relative motion, so acceleration is 0, definitely we can say that both of them are inertial frame of reference. If one is accelerated linearly, then 50 GS force comes into play. So in this manner, this 50 GS force helps whether a given frame of reference is accelerated or it is non-inertial.